thank you for joining us for this session on machine learning for good. This is a collaboration between CCG and Metropolitan Ministries. Allow me to introduce myself. My name is Brian Beesley. I lead delivery of data science projects at CCG. We are a consulting firm based here in Tampa, Florida. We focus on analytics solutions and services, and excited to bring you this presentation today. And I'll hand it over to Karen to introduce herself.
Thank you, Brian. My name is Karen Romano, and I manage donor data and analytics for Metropolitan Ministries. Metropolitan Ministries is a local nonprofit serving the Tampa Bay community. Our focus are poor and homeless people, and our goal is to instill self-sufficiency, allowing people to move out of the cycle of homelessness.
So, this being an innovation summit, we wanted to take the opportunity to talk to you about machine learning and how we've used it in the Tampa Bay community. Now, machine learning is something that is all over the news. I'm sure you hear about it constantly. There are so many use cases out there that are really exciting. I mean, you can now, for example, speak into your phone and it understands you and will answer the question you may have asked it, or perform some task. Cars are being built so that they can drive themselves around and navigate to your destination. Machines are now able to do things that was once the realm of humans only. And so it's exciting to see these things, and we see these use cases in the news all the time. But it can be very difficult, probably, as someone who maybe owns and operates a business yourself, to figure out how can you apply machine learning as a concept to your organization. How can you see the benefit from these exciting advances? Right? You probably aren't building a self-driving car. You're probably not building a computer that can play chess, but you do want to make your computers smarter, and you do want them to help your business reach the next level. And so today, what we're going to do is walk through just a high-level overview of what is machine learning and how does it operate. After that, we'll talk about a use case at Metropolitan Ministries where they were looking for the benefits of a machine learning analysis. And then we'll dive into how we applied the machine learning techniques to their specific situation. And my hope is that after hearing this, you might have some ideas yourself about ways that machine learning might help drive your business forward. Okay? So let's dive in. What is machine learning? Machine learning is essentially a new approach to telling machines how to make predictions. So if you think about it, in traditional computing, we typically tell the computer how to make a decision, right? If you want to forecast some amount, you take the amount from that same amount from last month and maybe take the average of that with that same amount from last year, and then that becomes our forecast for next month. Right? With machine learning, we take a little bit of a different approach. And what we do is we start with a hypothesis. It's usually a pretty bad hypothesis. We take that hypothesis and we tell the computer how to know whether it's a good or a bad hypothesis. So is it very far off from the reality, or is it very near to the reality? Right? Does it do a good job of predicting those values, or a bad job? And then we tell the computer how to adjust that hypothesis just a little bit, so that it improves each time that a small adjustment is made. And then we repeat that process with lots of data and lots of use cases, so that the computer has an opportunity to find patterns in the data that help it to solve the problem better and better. And we do that until either the computer can't get any better with the data that it has in front of it, or until we're satisfied with its performance and letting it continue to run just wouldn't yield any material advantage to us. So that's the process as a whole. And there are many flavors of this. There are lots of ways that you can apply these 4 steps. But this is the basic idea behind all machine learning algorithms. They all do some form of these 4 steps. Okay, and so I want to make it a little bit more real and dive into one particular approach to this process, which is the approach called decision trees. So let's imagine that we want to identify the animal in an image, in a photograph, right? And so maybe we come up with a hypothesis that the best way to identify an animal is whether it has more than 2 legs. And if it has more than 2 legs, we say it's a dog. And if it has 2 legs or fewer, we say it's a human. All right, so we have a hypothesis. Now we need to evaluate that hypothesis, right? Well, if we expose that system to more data, we discover pretty quickly that that's a bad hypothesis, right? There are lots of animals that have more than 2 legs that are not dogs. There are lots of animals that have 2 legs or fewer that are not human, right? So now we need to adjust the hypothesis, and there may be a few ways we could go about that. We could change our top line hypothesis, right? Maybe instead of saying does it have more than 2 legs or not, we could say does it have ears? Does it have fur? Does it walk upright? Right? So there are several things we could do that, or we could extend our analysis by creating a deeper tree. And so that's what we'll do here, right? So maybe we say if it has more than 2 legs, we look at whether its ears are in an up position or a down position. And if it's up, we say it's a rabbit. If it's down, we say it's a dog, right? And if it has 2 legs or fewer, we say does it wear clothing? And if so, it's probably a human. If not, then it's a snake, right? And of course, as we all know, that would still be a pretty bad set of hypotheses. So we want to repeat, right? And we're going to continue to do that until we come up with a decision tree that gets us to an adequate amount of accuracy, right? That says we're able to, with an acceptable amount of accuracy and precision, identify the animal that is in this image. So that's one approach to machine learning. And now that we've given you kind of the backdrop, the context of what is machine learning and how does it operate, in order to tell you how we applied it, we need to give you some background on Metropolitan Ministries and the business problem that they had in front of them. So I'm going to hand it over to Karen, and she's going to talk you through the use case the Metropolitan Ministries was facing.
Thank you, Brian. So we've discovered in the past couple of years that our overall donor base has been declining. Our largest segment of donors has been shrinking. In fact, this segment is down 9%, but this segment comprises about 90% of our total donors. Historically, the investment in new donors would pay off in repeat donors. However, new donors are increasingly less responsive to direct mail than they have been in the past. We found that other organizations like ours are experiencing a similar decline. What is the impact of that? Well, over 5 years, those lost donors represent a loss of about $1 million in revenue. That's the equivalent of over 2.5 million meals we can't serve, or almost 150,000 nights of shelter we can't provide, or 700 children who cannot attend Promised Land Early Childhood Education Center.
So what is a machine learning approach to solving a problem like this one? The way that machine learning and predictive analytics typically works is you need to define a single use case per analysis, and then you can create predictions for that one use case. So the use case that we really honed in on here is for givers who have given previously, are they likely to continue giving and be retained, or are they likely to attrite and stop giving, right? And you might approach that analysis by using those decision trees we walked through before, right? So our approach was to build decision trees by asking questions like, have they given consistently, right? Do they respond to direct mail appeals or not? Are they a new giver? Do they have the right demographics? Do they respond to appeals? Are they so there are all sorts of questions that you can ask. Now the challenge is translating answers to these questions into things that the computer can understand. So the challenge is, how do we tell the computer what the answer to these questions are, so that they can arrive at sort of that bottom line, which is, a green check mark for yes, they did continue giving, or no, they didn't, which is that red X, right? And so what we do is we're going to take a look at individual donors, and we're going to take a look at their behavior over time. And we have the benefit of being able to look back on history and know what the right answers were had we done this analysis at different points in the past. So what we'll do is we'll imagine that it's April 2015. And as of that time period, we'll look back and say, over the last 18 months, what was their giving history? What was the history of the marketing touches that they received? What demographics do we know about these people as of that time? And then we can look forward 18 months from that time and say, in the next 18 months, did they give again? And we have the benefit of knowing the right answer is either yes, those people gave again, or no, they didn't. And then to make our analysis more robust, we can repeat that, right? And we can do the same thing. We can look at those people from October of 2015, right? And as of that time, what was their giving history? What was the history of their marketing touches, right? What did we know about them demographically? Did they give again before April 2017, right? And we can repeat that analysis and say, based on how their giving history changed over time, and based on how the interaction that they have with the organization changed over time, right? Are there changes to their likelihood to continue giving, right? Now, I've thrown sort of 3 categories of data out here on this slide: giving history, marketing history, and known demographics, right? And the challenge is, how do we make those things understandable to a computer that doesn't speak our language? And the way that we do that is by coming up with summary statistics that represent each of those things. So in the giving history category, we might think of, what is their lifetime giving amount, and how long have they been a donor, right? What is the average time that that lapses between this individual's giving? And then, are they overdue based on that, right? Have they given a gift within that time frame that is their normal gift giving time frame? From a marketing perspective, how many times have we sent them appeals in the past year? Are we sending them more appeals or fewer appeals than we had before that? Demographics could be all kinds of things: age, marital status, location, political affiliation, incomes. And so we can expose all of these characteristics of those donors to the computer if we know them, and we can say, and we can let the computer figure out which ones of these are the important ones for drawing those decision trees, right? To figure out which ones are likely to give again and which ones aren't. And so what we did is we created several decision trees. So instead of just creating one of those, because if you can imagine, right, doing a single rule-based decision tree probably isn't going to have very good predictive power. But what we did is we created several of those. And each one of those trees would give that individual a percentage likelihood to continue giving. And then each one of those trees would get a vote in sort of the final likelihood that we were going to score that individual, right? So if one tree says they're highly likely to give and another tree says they're moderately likely to give, we might give that person an 80% chance overall, but they're likely to continue giving. Okay. And finally, what we do is we look at the outcomes of our model historically. Now, in order to do this in a responsible way, what we do is we actually hold out some of the donors from our decision tree creation process. So we selected a random set of donors that we didn't include when we were creating the decision trees, and then we took our decision trees, we applied them to our set of donors that were held out and said, okay, how well are we performing on this new set of data that the model hasn't seen before? Okay, and there are 2 ways you can really think about how this model is performing. One of them is if you just draw a line at 50%. So if you look at the chart in front of us, across the bottom, we've got a predicted likelihood to continue giving. So think of that as their likelihood score, or a bucket that they fall into. And then if you look vertically on the chart, that's the percentage of donors that were actually retained after that point in time, right, where we did the analysis. Okay, and so you can draw a line at 50% and say, everybody, more than 50%, we're going to treat as yes, they should continue giving, and everybody less than 50%, no, they shouldn't. And if you were to do that, we would be accurate 79% of the time. So that's not terrible, right? Another way you can look at this is to actually look at each one of those sort of score buckets individually and say the people that we scored between 90% and 100%, 98, 99% of them actually continued to give, right? You move a couple buckets to the left and look at the bucket that says 71% to 80%, right? About 65% of them continue to give. Continue on down, you see that if we look at the 30 to 40% range, right, it's about 38% of them continue to give. So the scores that we're giving these people actually do correspond with their propensity to continue giving, right? 90% of the people that we scored in the 90% bucket actually continue to give. And that tells us that our model is performing fairly well. So that's our machine learning approach. This is a way that we can let the computer learn from the data and figure out what Metropolitan Ministries can do to enhance its retention of donors, right? And one of the ways that might shake out is if we look at the donors that fall within each of these buckets. What we have on the screen right now is a frequency diagram. So again, we have those same buckets from 0% likely to continue giving to 100% likely to continue giving, right? And vertically now we have the number of people that fall in each of those buckets. Right? You can see the vast majority are in the 95 to 100% range. Those are probably the people who give on a repeating basis, who's giving maybe automated, right? So those people are highly likely to give again, and you might be able to maintain them as givers, even if you're not sending them as many marketing touches. On the flip side, if you look at the far left end of the scale, right, those who are very unlikely to continue giving, maybe it's not worth continuing to spend money on giving them those marketing touches because it's a losing battle, right? But where the value is probably those on the bubble, right? Those on the 30 to 50% range, right? That you might be able to tip over the edge and get them to continue giving, right? And so that might be a place to focus your marketing efforts and increase the drive on those particular leads, right? I'm going to hand it over to Karen to continue the discussion of how Metropolitan Ministries is planning to use the results of this analysis. Karen?
Thanks, Brian. So I shared that our donor base has steadily been declining, but our revenue growth has been fueled by a strategic plan to build relationships with our top donors, and it's been extremely effective. CCG was able to identify an additional band of donors who have a strong potential for greater giving, and that band of donors are represented in the middle two blue levels that you see on the chart. To help compensate for lost donors, we can reallocate some of our direct mail dollars to digital or other strategies, and we can invest in other revenue streams such as social enterprises like Inside the Box. To continue to grow our revenue stream, we can bring on more staff to build relationships with more donors, or we can bring in volunteers to send thank you notes to donors. Every dollar gained is a dollar invested in the Tampa Bay area. CCG has given us unique and valuable insights into our data that we can act on.
Thank you, Karen. So we hope you've enjoyed this overview of what machine learning is and how it really can be achievable and attainable for your organization, how you can unlock the power of your computers to really do the thinking for you, right, and help drive your decisions. based on the data that you have available. If you'd like to get in touch with us, the contact information is on the screen. Metropolitan Ministries is doing great things in the Tampa Bay area, so please reach out to them. And of course, we at CCG would always be happy to discuss your analytics needs and how to help you apply machine learning. So thank you very much. Hope you enjoyed it.